Okay, here we go with another one. This is coordinates. Coordinates and Pythagoras. Okay, this is 15, lesson 15. Okay, so coordinates are written like this. So we do coordinate A, and they're written in a bracket with two numbers, and the first number represents the x value and the second number represents the y value. So what we need to do to find out where this is on our grid is look along the x till we get to 5 and then go up till we get to 3, and there is where A is. And B, minus 3, 6. So we look along the x till we get to minus 3, and then we go up to 6, and that's where B is. We do one in each quadrant. C, we make 4 minus 4. So we go along to 4, and then down to 4 for C. And D, we're going to stick in the bottom left-hand corner. So these are all minus numbers now. So minus 6 on the x-axis, we go along to 6 there, and then we go down to minus 2. So that one is D. That's how to put a point given coordinates. The first number is x, the second number is y. So let's do another one. There we go. And I'm going to need a few of these, so do forgive me for not drawing this out first hand. So, but it gives you a chance. I suppose you could do one of these, and then if you could get hold of a photocopier somehow, you can just rattle off loads of them. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 1, minus 2, minus 3, minus 6, minus 7. Right, okay. So next part we're going to look at is how to work out midpoints, the midpoints of two lines. So we're going to go plot A and B. So that's the points A and B, and we're going to say A is minus 5, 3, and B, oops, B is a bit messy, need a little while to catch up there, BB, and then we're going to draw the line AB, and then we're going to calculate the midpoint and give the coordinate. Okay, so here we go. A and B. So minus 5, 3, minus 5 along and up to 3. That is A. And B is 3, 3. So along to 3 and up to 3 is B. Draw the line between them. Now let's try to do it in a different colour so we can see our line. So we're going to go from there over to there. Okay, now the midpoint. Now just count the squares because it's a horizontal line. 1, 2, 3, 4, 5, 6, 7, 8. So halfway along is 4. 1, 2, 3, 4. There. And that's the midpoint. And the coordinate of the midpoint is going to be minus 1 and 3. Minus 1 on the x, 3 on the y. So minus 1, 3. Okay, now we do the same with a line C and D, the line CD. And so we're going to have C is going to be minus 4, 1, minus 4, 1, and D is going to be minus 4, minus 5, minus 4, minus 5. So we're going to plot the coordinates, plot the line, draw the line, calculate the midpoint, and give the coordinate of the midpoint. So put the M there. Right, okay, C is minus 4, 1. Minus 4, 1 is there. And minus 4, 5. Minus 4, 5. Oh, don't want it to cross the line, so we'll make it minus 5. Minus 4, minus 5 is down there. Okay, draw the line between them. Nice and easy this, yeah? Draw the line between them. Label them all up so everybody knows what's going on. And the midpoint. So 1, 2, 3, 4, 5, 6 squares. So you can go up or down from the end. 3 squares, 1, 2, 3. There. There is the midpoint. And that has a coordinate of minus 4, minus 2. So the midpoint becomes minus 4, minus 2. Okay, see what else we've got. Right, so let's have a diagonal one, yeah. I could actually no, I won't. I'll copy. Right, what I'm going to do with this diagonal, because I'm just going to use I just yeah, don't forget that bit. I'm just sort of going to just do the positives, yeah. 1, 2, 3, 4, 5, 6, 7, making the scale a bit bigger. 1, 2, 3, 4, 5, 6, 7. This is still the Y and still the X. imagine we've sort of just zoomed into 1/4 of the whole thing. So the midpoint of a diagonal, right, so we need a line AB, and A is 1, 2, and B is 6, 4. So let's plot those. 1, 2 is there. 6, 4, it was a bit bigger this one. 6, 4 is there, and join them up, not forgetting to label as A and B. Doesn't matter which way round A and B are. Right, so what we're going to do is calculate the midpoint. Now, you can't count squares, so there must be another way to do that. There is. Remember that this is the X, and this is the X, and this is the Y, and this is the Y. We've got to find halfway between this X and this X. So if we add them two together and divide by 2, we get 7 divided by 2, which is 3.5. And this is our X value. And the Y's, we get 2 plus 4 divided by 2, 6 divided by 2, which equals 3. Two and four. 1 and 2 and 4. Yeah, 2 and 4, 2 and 4, which equals 3. And that's the Y value. So the midpoint is going to be 3.5 and 3. So let's find out where that is. So 3.5 is here. So go up till you get to your line there, because it goes back to 3 there. So there's the midpoint, drawn and calculated. Now we need to do that calculation because sometimes we don't even get the graph. So what do we do when we don't get the graph? Right, let's come back to a different colour, not a better colour. Yeah, find the midpoint. Okay, find the midpoint of these. A is 3, 3, and B is 13, 21. So add the x's together. 3 plus 13 divide by 2, 16 divide by 2, which equals 8. And the y's are 3 plus 21 divided by 2, 24 divided by 2 is equal to 12. So therefore the midpoint is going to be 8 and 12. So you can do it without even the graphs. Do another one of these. A and B. So A is 0, 2 and B is 9, 12. So 0 plus 9 divided by 2, which is 9 divided by 2, which equals 4.5. That's the x. And the y's are 2 plus 12 divided by 2, 14 divided by 2 equals 7. So the midpoint here is going to be 4.5 and 7. Yeah, good. Right, okay, so what else we've got to do? So now we move on to Pythagoras, because we're going to use Pythagoras later on when we go back to the graph. Now Pythagoras is all about right-angled triangles, and the easiest one here is 3, 4, 5. Now the longest line here is always called the hypotenuse, yeah, and it's the one that's opposite the right angle, and this is Pythagoras for right angled triangles only. Yeah, and what happens if we call this ABC, ABC, the Pythagoras theorem, or the formula to find out the unknown sides, is a squared plus b squared equals c squared. Now let's find out if that's right. A squared is 3, so 3 squared plus 4 squared equals 5 squared. So 9 plus 16 equals 25. Yeah, 9 and 16 is 25. 25. And this works for anything. Absolutely anything, except you remember the ABC bit, but the sides are often X and Y and Z. So don't worry about the names of the sides that we've got to find. So here's a triangle, yeah, so we've got 6 and 8, and we have to find this one, which is X, the hypotenuse. So we go 6 squared plus 8 squared equals X squared. 6 is a 36 plus 64 equals X squared, which is 100 equals X squared. So now just the last little bit to find the actual length of the side, we need to square root this one. So the square root of 100 equals 10. And it's not going to be a minus or plus 10, it's just going to be 10, and in whatever units that you're using. So that's how to find the longest side when you are given the two shorter ones. Now if you're given one long and 1 short, you get this kind of thing. And this obviously not to scale because I'm just drawing these freehand. Say we don't know that one, and that's 20 and that's 15. Now this time we subtract. Instead of adding the 2 short ones to make the long one, we subtract the short from the long. So we go 20 squared minus 15 squared equals x squared. So this is c squared minus b squared equals a squared, that one. Other way around, yeah? So that's 400. 15 squared, whatever's that? 225 equals x squared. So that from that is 200, 175 equals x squared. And the square root of 175, which will be the length of x, is 8.48 sort of things, yeah? I don't know. This is a prime case for they're going to ask you to round to so many decimal places, of which I haven't. It was 8.48528 on the calculator, so I can go 8.5 to 1 decimal place, or 8.49 to 2 decimal places. Yeah. Okay, so I don't know whether we've got another one of these. Yeah, let's find the one at the bottom now. So we found the one over the left, so let's find the short one at the bottom. So here's our triangle. And now we're going to find the bottom one. So this is going to be c squared minus a squared equals b squared, yeah? So 11 squared minus 7 squared equals x squared. 121 minus 49 equals x squared. 72 equals x squared, and the length of x is going to be the square root of 72, which is 8.5 equals x, and there'll be centimeters or meters or inches. Now what we need to do now is put this Pythagoras into practice with a graph. So let's copy that and stick that right down the bottom to where we are. Alright, so let's move it over there a little bit. And what we're going to do, we could, yeah, we'll do this, yeah. We'll do the whole thing so that we're not, oops, doing it with a mouse there, that's not good. So let's come over here. So we've got x and y, and 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Now, two sorts of things they could ask us here. They could ask us to work out the length of the longest side, or they could ask us to work out an area. So what we're going to do is plot the line AB, where A is minus 6, 2, and B is 2, 6. Now find the length of AB. Okay, so let's plot it first. A minus 6, 2. Minus 6, let's do a different colour. Minus 6, 2, there. And B is 2, 6, which is up there. Okay, so label, always label. Let's join them up. Now, they will always say something like this as 1 square equals 1 centimetre. And they'll never draw this exactly on the exam. So this square is a centimetre. So no good measuring, yeah? No good measuring. What we're going to do is find out the length of this line by using Pythagoras. So we need to make a right angled triangle. So if we go from here underneath there, and when we go from there down to here, yeah, so we've made a right angled triangle. Let's measure the sides of the triangle. 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now to find the hypotenuse, which is x, yeah, or AB, is going to be 8 squared plus 4 squared equals AB squared. Yeah, so 64 plus 16 equals AB squared. 80 equals AB squared. As both of these squared, yeah. And so the square root of 80 equals AB. And the square root of 80 is 8.9 centimeters, yeah? So we didn't have to measure. If you measured that line with a ruler, it would not be 8.9, I guarantee. Equals AB. Now the next bit we can find is plot the triangle we call it ABC again, yeah? ABC. Okay, we could have also done it on the triangle that we've already done. That would have saved a lot of bother, wouldn't it? Triangle ABC. So A is minus 7 minus 7. B is minus 7 minus 2. And C is minus 1 minus 7. So let's plot these and hope we come up with a triangle. So minus 7 is there, which is A. Minus 7 minus 2 is there, which is B. And C is minus 1 minus 7, which is down there as C. So now we can draw that as a triangle. There. And let's do the measurements. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So the area of a triangle equals half base height, which equals a half times the base, which is 6, times the height, which is 5. Now 6 5s are 30, half of 30 is 15. So it would be 15 centimeters squared. Okay, that's the lesson on Pythagoras and coordinates.